Hi there, and welcome to the next part of this tutorial series where we expand on our previously implemented Toon shader from the beginner's tutorial. So during the last two episodes, we implemented the FBX SDK and actually got it up and running. We parse our, let me see, just close this. We parse our vertices, and this is from one FBX file. We are able to load all of these models here. So let's see. We will be moving on to so-called deferred rendering, which means that we will set up a pipeline where we actually don't render to a ordinary render target, but to a series of textures that will control the scene. Whoops, the scene. The scene geometry depth and normals and so forth. And we will use that to sample in our final pixel shader. That also means that the rendering of each pixel is actually deferred, and it's a method to avoid so-called overdraw, where you keep on drawing different objects on top of each other if they're not ordered by their depth value in the scene. So if you were to draw pixels for every object you render, you might draw in another object on top of it. Let me show you just here in the project. So if I draw this object here first and I shade the pixels, if I draw this object on top of it, between this object and the camera, I would have to reshade all of these pixels here on this object. And therefore, I would spend a lot of time in the pixel shader or fragment shader, or whatever you call it, and wasting a lot of resources, kind of like redrawing each pixel over and over and over. So what you do with deferred rendering is that you postpone the actual coloring, and you just write information to a series of buffers, textures, and you use that to do the final light calculation. Deferred rendering also allows you to implement several lights, since you can easily imagine that you were to, again, calculate the pixel for this object first, and then you would maybe have 1,000 lights. So you would calculate the 1,000 lights effect on this pixel, and then you would draw another object on top of it, and you would have to do it for all the 1,000 lights again to get the new pixel value. So by using deferred rendering, you only check for the lights effects on that particular pixel once. So yeah, you kind of like defer the actual rendering itself, and you just do some preliminary computations. You don't do so-called overdraw. And the pixel shader is one of the most expensive parts of the shaders, because imagine how many pixels there are on a 4K monitor. Anyway, I made this change here to our graphics command list API before we were casting this to a graphics list pointer. And we don't want to do that, because what if it fails and stuff like that? So I've implemented actually trying to query for the interface instead and storing it in the pointer. Okay, and we should be fine closing the application as well. Oh, we have some live objects here. Yeah, we could release them, but we don't care. It's not the focus of this tutorial series anyway. Maybe, although, let's just make sure that we actually, let's see, commands here, on release, if we have a, let's do reset release or where? Yeah. Okay. Let's see, of course, this as well. Yeah, and did it clean up our live producers? Yeah. No. Oh, we have the shadow transform buffers and the device itself. Okay. Let's add in the render API here. To do improve release function to clean up objects. Yeah, so you would need to fill out this. Fill out this stuff. Okay. Anyway, that was some preliminary improvements. I also changed the draw calls during the draw step here, just to fiddle around with it, but no or major changes were implemented. All right, so what we're going to do is actually we're going to modify our vertex and pixel shaders here in our resource, or rather pipeline. In order to implement deferred rendering, we need to, let's see, in order to do deferred rendering, we need a render target descriptor heap. We also need to bind some resources. Do we have descriptor heaps implemented? I don't think so. Do we? We do have descriptor heaps. Great. Oh, we probably use them for the depth buffer. Yeah, we do. Depth heap. Yeah, okay. So we need to create a different one for shader resources. Anyway, let's just start by doing our modification to our pipeline. So let's create a new pipeline here that we will call, let's see, where are our pipelines here? Base pipeline. Let's do a D12 pipeline here. State called deferred rendering pipeline, or maybe just a deferred pipeline. Okay. And in our render API, we have all of our essentials here. Let's see. Let's scope this. Essentials. And let's do load our FBX models. Okay, and let's put that in a scope as well. Yes, and then we want a deferred pipeline initialize. And let's see. Right now we create different initialization functions, it seems. Yeah, so we actually don't need to, well, let's create a new folder here. Let's do deferred here. And let's do base. And let's just move these two here into the base. And let's call it base. Base. And everything should be fine. No? Oh, we're doing something wrong somewhere. Yeah. Okay. We should be fine. Yeah. Okay. Yeah. In order to just do something that is void initialize deferred. Let's implement that. Let's see. And let's copy all of this. But let's do deferred here. And let's actually add the shaders. Let's do a pixel shader and a vertex shader. And let's not compile them through Visual Studio. And let's see, are we allowed to actually do this? Initialize deferred mdevice.get. Do we have any problems doing like this? No, no problems at all. Okay. Okay, so when we initialize a root signature, yeah, let's just use the same root signature. So we have material transform. Yeah, let's just do this. It'll be fine. Okay, so we want to compile of shaders. That's fine. And then we want something. We don't want blending. We don't want. But we want to do some stuff. Number of render targets and so forth. This is our deferred stuff here. We'll have our position and normals. We will have a depth buffer as before. Let's see, front and then true here. Whoops, on the other one. True, let's see. Yeah. Okay. I just changed the calling mode to front so it makes more sense than just the winding order to be counterclockwise. It was because it changed whenever we imported the FBX models. Okay, we do not have any of this stuff here enabled, so, and we don't do sampling, we do our stuff like this. We write all our depth values. Okay, so let's see, deferred rendering, gbuffer. So if we, for instance, look into our gbuffer here, it contains a position, some normals, and some albedo. That's at least one way to do it. Let's see. What we want is maybe something even more than that. But it's a great starting point. So position, normals, albedo, and not specular. Yeah, so we will do 4 render targets or what? Let's see. So position. Let me see. Will be in world space. And it will be XYZ. Then we will have our normals in world space XYZ. Then we will have our albedo, which will be color RGB alpha. And then we would want something like maybe we want something like maybe we want something like, so when you're doing like outline prediction, you can use the normal and the depth as a way to generate outlines, but you can also use the material indices. Let's do something like potential add-ons, either in the last fields of each. Yeah, maybe we just want to do like, and then the W equals object ID, and the what do you call it? W here is equal to the material index. I don't know. We could pack it like that. So that would mean that we Yeah, this would be probably more efficient than creating a separate buffer. Yeah, so let's do that. So let's do 3 render targets. Right now we have the first render target, which is in this format here. Let's increase the size, or rather resolution here. 32, 32, 32, 32. It will take more memory, but um, um, it's what we're gonna do. Whoops, I'm jumping around here. What I'm basically doing here is telling this pipeline that you should expect 3 render targets. And they should have the format of 4 floats, which are 32 bits. Maybe not. Well, that's the problem then. I guess you could cast it, downcast it. Yeah, I think we can cast it anyway in this shader. Yeah, so we want 32 bits for 4 values, red, green, blue, and alpha. And we want our shader to actually output into something like that. So right now this won't compile because our pixel shader only outputs to 1 render target. Let's see if I'm correct here. Oh, it's not whining right now. Okay, it doesn't really care right now. Anyway, so we actually need a custom descriptor heap for these 3 render targets. We also need to create some resources. Right now, we don't have any texture resources as far as I remember. Let's see, resource here. Yeah. Let's see, can we actually... Yeah, okay, so we need to do a couple of things. We have a descriptor heap here. So right now our swap chain is actually holding our so-called render target views. So remember, we have these render target views, meaning that whenever we bind a output to our, or rather maybe we should say an input to our swap chain, whenever we want to render to the back buffer of the swap chain, we use a render target view to address that. So whatever we draw onto the back buffer, and then the back buffer gets presented through the swap chain. But the swap chain kind of like has its own RTV render target view heap. Um, we basically want something like it on our render API. Let's see, let's close a lot of this stuff here. Yeah, so let's create some code for that. Let's do descriptor heaps. And right now I'll paste the code. We have, did we include descriptor heap? Yeah, we do have a depth descriptor heap. Descriptor heap deferred render targets. Let's do that. And inside this, let's error creating the deferred pipeline render target views. Let's see. Oh, yes, this one. Right. Or do we just need this? I don't know. Let's see. Oh, it's just a pointer then. Let's see, mdevice. No. There we go. Okay. And let's see our descriptors. The deferred pipeline uses pre-render targets currently. Next, we actually want a descriptor heap that can hold so-called SRVs. Usually they are implemented in somewhat the same way. So yeah, so let's do void initialize constant. This is a combined buffer for constant buffers, or rather descriptor heap for constant buffers, SRVs, and UAVs, unordered access views. And that's basically the way that DirectX does it. Yeah, basically we could use, we could create, let's see, const unsigned int num descriptors. We want to specify how many descriptors, and let's do this number of descriptors. And let's do this with no flags. But we could look what flags we could use. Descriptor, heap flags, shader visible. Yeah, we could do different flags, but we don't care, we don't care, we don't care. So we will create a thingy here. We could also just create an RTV here, and then collapse this code into our thingy here, and then we, huh? Oh, it's because this is called desk instead. There we go. So let's just do initialize. Oh no, not like that. Initialize. No, not like that. And let's do the device dot get. Hi there, Manka Manka. I'm busy recording right now, so I'm not going to reply much. Let's just do 3. And then we can actually collapse this code into this. And then you wouldn't know this, but our descriptor heap I don't know. Try watching through these tutorials. I'm uploading them here on the channel and see what you think. So we initialize the render target views. Right now we can't do anything with this deferred heap here. But let's implement some of the what do you call it, functionality to actually use the descriptor heap. A descriptor heap is, as I've probably mentioned before, a series of like descriptors or descriptions of different resources, where to find them in memory, and how to interpret them by the GPU or the DirectX API. So we have created our pipeline here that uses these 3 render targets right now. We have created our pipeline, but in order to be able to do anything with it, I don't know what's harder. I guess it's a matter of preference. All right, let me see. So whenever we create this pipeline here, let's move it up so we can see that this is our old stuff. Old stuff will be removed. Then regular depth stuff. All right, so we have our descriptor heap, so that means that we can now allocate so-called descriptors to our resources, specifically our render targets that our deferred rendering pipeline should use when it outputs from the shaders. So these shaders here are basically bound to these render targets, and I'll show you how to couple them when we're done and actually can do some rendering. But right now we don't actually have any resources. So that means that we actually need some render targets. Okay. So in our renderer API here, we need some resources. Let's kind of like place these in the area vicinity of each other. This is system stuff. We don't want to mess with that. Old pipeline stuff. The depth buffer is for all of our pipelines right now. So new deferred stuff. So let's do a D12 resource array here. Deferred output textures. And let's create 3 of them. Remember, we wanted 3 outputs here. Using this stuff like this workflow here. But right now we can't create resource textures. So that basically means that our resource function, resource here needs to be able to be initialized. Right now it's possible to initialize it as a dimension buffer, and it's possible to initialize it as a depth buffer, but it's not possible to initialize it as a texture. So we want something that can initialize as a texture. Maybe not A here. And then we of course want the width and height, and we also want something called the format. So let's see. Also, I think, yeah, row major is fine. Let me see. So we want the format, which is DXGI format here. Const DXGI format, and we want the format here. And perhaps we want a depth value, maybe not. Huh? Did I? Oh. Okay. Let's create it on the default heap. Is this whining about something? Depth buffer. Okay, let's just. Oh. I'm messing around here. This is not the way to go. I'm put it the wrong place. There we go. Okay. Let's copy all of this. Almost all of it. Okay, so we want a texture 2D with the appropriate alignment. We want a depth of 1. We don't want MIP levels. And we want our format here. And let's do no flags. Or rather, no, we need to pass the flag allow render target here. Otherwise, we can't actually use it as a render target. And let's see. Error creating texture resource. And we don't want, let's do it in a, okay, so we need to transition out of the common state. Let's see what's it's whining about. Oh, the clear value, of course. Optimized clear value. Let's see. Create committed resources. Optimized clear value. Okay, so we can actually do the clear thingy here. Okay. Let's see if that works. Hello guys, how's it going? I'm recording the next episode in this tutorial series here. So I'm not gonna reply that much. Let's do a const unsigned int render targets. Let's do 3 here, and then a for loop. In I, and I is less than the render targets. Render targets here. And we should take our deferred render targets or output textures here and initialize them as textures. And with our width and height, which we get passed in when we create this. And remember our actual format here in our pipeline state. So this is the format that we will, excuse me, try to create them in. Let's see if we are allowed to do what we want. We have no problems doing that. Great stuff. All right. So now we would like to bind our resources as render targets and also transition them into the correct state. Yeah, so let's see, we do queue some commands here for our upload. And we actually execute them all the time. Let's see. Yeah, so we could do some recordings of our resource transitions here. So let's create a resource barrier, as we do right here. And let's do And let's delete this. Okay. Oh, we need to set the barrier resource here. And let's do the common resource render target. So we will prepare a barrier here and record the transition of this resource here on our graphics command list. And whenever we upload something to the GPU through our upload service, we will actually also do this resource transition. So let's see. Transition dot resource, and let's do this dot get, and this should work. Yeah, so it gets transitioned into the render target state, which we want for each resource. Okay. Then we want to actually do something like device create render target view, and we want to pass in our resource here. We should also create a render target view description. And then we need a CPU descriptor handle. So what that means is on our descriptor heap, we actually we get two mappable addresses, which are one for the GPU side and one for the CPU side. And this one needs a CPU side in order to be able to bind the render target view. So we need to do that. We also need a render target view description, of course, and we can grab that from our oh, that's the swap chain description. We can grab it from, oh, well, I actually think the swap chain itself fills it in. Yeah, okay. So we can't grab it from the swap chain. We have to create it ourselves. So let's start out by doing that, and then we will implement the actual indexing render target view description. D3D12 render target view description, view disk. And let's set the values. So let's see, it wants the buffer, which we won't set right now, but we will set this format here. We will set some parameters, view dimension. Let's see. Do we actually set that usually? Let me see. I'm just gonna look what I usually do. Oh, we can actually pass a null pointer, so we don't need to do this for a render target. So it will infer it by itself, and then we need the descriptor handle on the descriptor heap. Okay, let's comment out this code here and finish it. So one thing we haven't done, which no, not this one. The descriptor heap here, should actually store some some information. It should store something about how many units or whatever it's containing. So let's call that size. And then we need a and I think it's something like a size t, but let me explain what it is. Let's see. And let's add it to all our whoops. And let's see, let's just do one here. So whenever we create these descriptors, depending on which GPU you have, you would have different sizes of them. So in order to be able to handle iterating over these descriptors that might be placed in a table or an array, aligned by different amounts of memory on the actual GPU, you need to actually figure out how much size is allocated to these descriptor handles. And you can see here, we can actually ask the device for its standard allocation size for this descriptor type here. And for RTVs, it's this way to do it. Let's do uint. Aren't we allowed to do that? Let's see if we are. Increment size. And let's do increment size and store it. And let's do that for the next descriptors as well. We could store it as well for this one, although right now we are only allocating one depth descriptor. But we will actually, let's do const unsigned int num descriptors and set it to 0. Because when we implement shadow mapping, we will actually use more than one depth descriptor. So let's see, m size equals 0 here, and increment size equals 0. Okay. Not that it matters, but now it's possible to reset this. Okay, so when we initialize, we store that value. Then we want our interface here to be able to actually return some descriptor addresses, both on the CPU. So let's start with that, descriptor handle, and get CPU handle. And let's do const unsigned index, which will and let's do the same thing for the GPU handle. GPU handle, descriptor handle, get GPU handle. Yeah. Let's say, and let's assert that we are index is lower than size here. So whenever we're in debug mode, we can get a notification if we are out of bounds. And then we want to compute our handle here for the CPU. And we will get the underlying interface and get the CPU descriptor heap handle for heap start, meaning the first address we would have, and then we simply increment the pointer by, this is all in size t, I think. Yeah, size t. We could actually do size t here. Usually you would pass a number. Yeah. Okay, so we don't need to do that. We can do index times. Also, this is a uint, but let's cast it to a size t increment size here. And then return our handle. So that's basically this CPU address. We will do something similar down here with our GPU handle, and the method is exactly the same. But this is a uint64. The addresses will be bigger. So here we should cast our values into a uint64, and then we can return the handle. So this allows us to specify an index. We could, yeah, I don't know. It doesn't really matter. Okay, so we have our descriptors here. And let's try to grab our deferred render targets. This should actually be called disk heap get CPU handle, and then we will simply pass our index here. And this should create our render target views. Yeah, so far so good. Then you would want to create a descriptor heap that can actually store so-called RTVs. It's render target views, or rather, let me start over. So we want to actually bind shader resource views. So far we've created resources that can be used as render targets. That means that we can render to them from our shaders, but we can't read from them. We can use the same resource as something that we can read from by simply creating a view that allows the users the resource to be used as a shader resource view, or a shader resource rather. So let's see, we could add that to our resources. We could do a union here, descriptor, or rather view, and we could do a D3D12 shader resource view description, I think. Yeah, view description, right? SRV. And let's do a function that create SRV. And let's do a device here. And let's do a view and view. And let's fill out the view. So mview.srv.buffer. Usually it's not needed, but we could do it, I guess. No, it's because it's different, right? Yeah, it's not a buffer, it's a texture 2D. So that's what I'm messing around with. Let's get the format here. We can get the description. Let's do a D3D12 resource disk, rest disk. Rest disk format. And let's do view SRV view dimension at texture 2D, since our render targets are this is the component mapping. And then we will fill out the texture 2D stuff. MIP levels, resource disk, MIP levels, and let's copy this, and most detailed MIP in this instance is 0 because yeah, it's always 0. Plain slash is 0. Minimum LOD clamp. There we go. Maybe we want to actually call this create SRV with our device here. Well, actually we don't need our device. It's outside this function. Okay, let's make it a private function. Let's see. Let's get a reference to get SRV disk. Rather return view.srv. So this gets called, and we can actually create it on the fly for the resource. So it gets called automatically. We don't need to do that. Let's see. We're still good right now. Not yet. Okay. All right, so now we can do the same thing just with a different type of descriptor heap here. So let's create a deferred SRV. And right now we are allowed to kind of like slap it together with our pipeline here, but I think in the future it should change. Initialize this with our device here. And we want to create 3 for now. We'll should hold our shadow map stuff in the future. So I should have another name eventually and bigger size. Anyway, let's see. So let's create shader resource view on our resource here. And let's get the description, get SRV, address, and let's get our CPU descriptor handle here. There we go. So we've actually bound our resources. So now we have created and bound resources. Now we just need to actually do some rendering. Let me see, how long have I been recording here? Okay, so let's just say that this episode ends here with us going into the render doc stuff. Let's see, let's copy our shaders and oops, not this, the release mode. Yeah, there we go. And then inside this directory here, we will create our shaders and see that everything runs. Okay, so I'm getting used to, no, let's use inside here. It might even be bound. Yeah, it's bound. So we do our frame capture here. And let's see all our resources. We have several textures which are in our render target. Common with our size here. So we could name them just for good measure. Now let's see, string in the PCH. Let's do some name computations. As far as I remember, it's a wide string. So let's do set name. Yeah. So let's do a stdw string. name, deferred render targets number, and then name append I plus 1. Let's see. We can't do that. Okay, std to wide string. There we go. Name that C string. Yeah. Okay. There we go. I had to override it. Let's look into this stuff here. So we have our resources, deferred render target 1, 2, 3, with the dimensions of our screen here. And as you can see, we're actually using 20 megabytes per texture. So deferred rendering uses some more memory, especially in 4K. You can imagine that this would get way, way bigger. Anyway, so let's see our descriptor heap here. Descriptor heaps, we haven't named them. We should probably do that. So this is with render target views, and you can see that it's actually our swap chain buffers. And then we have these 3 textures which reference the deferred render targets. And then we have a CBV, SRV, UAV descriptor heap, which also references this render target series. And then we have our depth view here. All right. Let's just add some stuff here. Set name, deferred rend descriptor heap. Let's do this one, set name, main CB SRV UAV descriptor heap. And I'll name it like that because it will be our actual what do you call it? Our actual main descriptor heap. And let's set the name here. Depth descriptor heap. Also, let's do 1 here. And let's see our depth buffer. Okay, so we've named our resources and we saw that they got created correctly. We created our descriptors, we created our descriptor heaps. So in the next episode, we will actually start rendering and customizing our shaders to be able to use this deferred pipeline. All right, if you found any of this helpful, inspirational, or entertaining, please consider supporting the channel by commenting, liking, or subscribing, or checking out the description with other ways to support the channel. You'll find the GitHub repo in the description as well, and you are welcome to join the Discord channel. All right, I'll see you in a bit.